Imagine trying to plug your computer monitor into a server, but that server is sitting over 6 miles away. Like, how do you keep the video crisp, the mouse actually responsive, and, keep the data completely safe from hackers?
Right. I mean, it sounds like an impossible task,
Yeah.
especially if you're just thinking about the standard cables you have sitting at home.
Exactly. So today, our mission for this deep dive is to translate a highly technical product page from HDTVSupply. We're looking at this piece of hardware called the Smart-AVI
Oh,
FVX-3000-PRO-TX-S.
yeah, quite the catchy name, right?
Seriously. And it's this dense $2,549.15 piece of equipment. So we're going to turn the spec sheet into a fascinating look at how the most highly sensitive industries in the world actually move their data.
Yeah, because it is a perfect example of how enterprise-level problem solving requires fundamentally different physics than consumer tech.
Okay, let's unpack this.
Yeah.
If you try to take a standard copper display cable and extend it, it's basically like stretching a rubber band.
Right, exactly.
You pull it too far, and eventually it just snaps. The signal degrades completely.
It's gone.
Yeah, and we know sending uncompressed 1080p video at 60 hertz alongside, stereo audio and real-time USB keyboard and mouse controls, that requires a massive volume of data.
Oh, huge amounts.
So how does this specific device manage to push all of that over 6 miles without dropping a single frame?
Well, the secret lies in a complete shift in the medium. It uses single-mode fiber optic technology.
Okay, fiber optic.
Yeah, so instead of trying to push electrical currents down a copper wire, which, naturally loses strength over distance, this device converts all of that data into light.
Wow, light. Which makes sense for speed, obviously.
Yeah.
But the specific term single mode stands out to me.
Yeah.
I imagine that's a different mechanism from the standard consumer fiber someone might have wired to, like, a residential street.
It absolutely is. I mean, standard consumer fiber often allows the light to bounce around inside a wider core. But single-mode fiber has a core so incredibly narrow that the light travels in just a single straight path.
So it's not bouncing off the walls at all.
Right. Because the light isn't bouncing off the internal walls of the cable, the signal doesn't degrade or lose timing over those 6.2 miles.
That's incredible.
Yeah, the video and the keystrokes arrive exactly as crisp as if the machine were, right under your desk.
But see, that massive distance introduces a totally new problem. If you are extending a computer's control over 6 miles away, that cable is leaving your building.
Oh, sure.
It is passing through public, unsecure areas, which naturally introduces the threat of interception. And here's where it gets really interesting.
Okay.
I have to push back on that price tag. Over $2,500 for a physical extender? Like, if a company needs to send secure data over a long distance, couldn't they just use an encrypted VPN over a standard internet connection for a fraction of the cost?
Well, what's fascinating here is the physical vulnerability of standard networking that a VPN simply cannot fix.
Wait, really?
Yeah. Standard copper cables emit electromagnetic fields. A sophisticated hacker can literally sniff those fields and reconstruct the data.
Without even touching the cable.
Exactly, without ever physically touching the wire.
So the physical copper wire itself is passively leaking the information out into the air.
Right. But fiber optics use light trapped inside a glass core. It emits absolutely no radio frequency.
Oh, wow.
So to steal the data, a hacker would have to physically cut into the glass.
And cutting the glass would sever the light beam, right? Which would instantly drop the signal and alert the control room that they've been compromised.
Precisely. That mechanism is why the source specifically highlights target demographics like military operations and government control rooms.
That makes total sense.
Yeah, they cannot rely on software encryption alone. They need an unhackable physical pipeline.
And if we look at hospitals from that source list, I mean, the same logic applies. Think about a surgeon operating a remote robotic arm.
Oh yeah, they would need those exact same zero latency, totally unhackable inputs.
Because a split-second delay or a network disruption there is literally life or death.
Exactly. And banking facilities are on that list for the same reason. You aren't just paying to send a video signal.
Right.
You're paying for the absolute physical certainty that no one else can monitor or manipulate it along the way.
So what does this all mean for you? Well, you might just use a cheap $5 HDMI cord to hook up the monitor on your desk.
Most of us do.
Yeah. But the institutions guarding your money, your confidential health records, and even national security, they rely on these heavy-duty physical light pipes to keep their systems completely impenetrable.
It really is a completely different level of infrastructure. Just quietly operating right beneath our feet.
It really is. Which leaves you with something to ponder today. If the most secure, well-funded facilities on Earth still insist on burying physical cables deep in the ground to protect their data from interception, well, how truly secure is the invisible wireless web that we all rely on every single day?